Hello. So we are back, but this time with a different type of job. So what do we have here? We have a Samsung S10 Plus, and this is a data recovery job. Okay. Now data recovery jobs are different compared with any other job. And behind of this phone, it's a very sad story. So doing a data recovery, your achievement is not to fix it. Yeah, like on any other job. Okay. So the main point here is to not create more damage. Okay, that's the main point on a data recovery job. If you cannot fix it, that's fine. It's okay. But we don't have to create more damage because the customer wants his data. If I cannot fix it, maybe someone else can. On a data recovery job, it's no rush. I mean, it's not like, okay, you are getting the same money no matter if you work 10 minutes or 4 hours. Data recovery is paid by hour. It actually is paying your time spent on this phone. So it's no rush in a job like this. I'll try to edit the video to make it shorter as possible, but I'm prepared for a very hard job here. So what's the story with this one? The customer used the phone. The phone has the screen has a mark on the screen has a mark on it, but the customer said the phone was working fine with that screen. On some point, the phone stopped working. He went to a phone shop to replace the screen, and the people from the phone shop said it's no point replacing the screen because the phone is dead. So we have to fix it so the customer can recover his data. So the plan is like that. We are opening the phone, we are inspecting the board, we are checking a little bit to see what current is taken from the charging port, from the battery, if it's reacting to the power button. If it's not, we are going on a basic motherboard inspection. We do have the motherboard schematic here. So we will be checking all the power sequence, starting from the power button, here with the power on. And then we are moving and checking the power rails, yeah, especially this one, VDD 1P8 AP. Okay, so this looks like it's like a main power rail on a phone which is always on. Yeah, always on. Also, the power button is kept on high, yeah, on a high state by this power rail, yeah, by this one. So that's the plan with this phone. Now let's start doing some work, okay? Like how I said, we have to fix this. Now I cannot show you the customer letter. It's a very sad one, so I will try to be very precise doing this job. Here is no place for mistakes, yeah? It's no place for dodgy work. It's no place for experimenting or playing with the power supply. So whatever we are using the multimeter mainly, but if we have to use the power supply, I have to be 100% sure I know what I'm doing. Okay, so that's the phone. You can see the phone has a crack on the screen, but that's not the issue. The issue, the phone is not working. Has a sticker, boot dead. So I don't know, the phone is not booting. If it's not booting, we should find a good board inside, right? With everything working, charging. Yeah. So let's see, I have the thermal pad here. Let's, the back cover is cracked. Let's heat up the phone. And take the back cover and see what we can find inside. Okay, it has been opened before. Sorry, it was proper stuck. Okay, the back cover is removed. Okay, let's plug a charger and see what we have here. So we have like 5 volts, we have 0.1 amp. The voltage, the current is quite stable, so possibly don't have a short on this board. Now let's check the battery. The battery is 1.8 volts, and I'm curious to see if 1.8 volts has because it's taking too much power from the power connector or not. I mean, we have a short there or why? Why is the voltage just that low? So I'll switch this to 3 volts with a little bit of current, yeah? Okay, that's ground. And that's plus. And on the plus line, something is getting like around 40 milliamps. And that's not okay. Yeah, so this is not okay, 40 milliamps. So I would say definitely here we have some a hardware issue. 40 milliamps is quite a lot for a phone which is on standby. Yeah, so the phone is not working. Now let's get out the motherboard and try and find out why and what is taking 40 milliamps. And the board looks like it's untouched, which is a good thing. So let's have a look for obvious things like liquid damage. Okay. So it looks like someone play here with something. Play with a solder iron. So they solder a wire here or what? Why someone it will play with a solder iron here? I'm, just curious. Because this is dangerous. If you use the plus from here to supply power to this board, uh, you never know what happened. I mean, with the battery, the voltage it will not goes over 4.2 volts, 4.3. If you are using a power supply and you are doing a mistake and you come there with high voltage, you will kill this board. I'm just watching for an obvious sign of liquid damage, but I can't see any. Okay, let's remove this shield. for the moment. Okay, so I took the shield out. Let's wait. Let's wait for the board to cool down. Let's check with the thermal camera and see where that 40 milliamps is going. Okay, so this is a tip, yeah, to identify a power issue. Like you see on our case, we have the power connected to the battery connector, yes, and it's taking like 40 milliamps. Now, if the short, it will be on this power rail, yeah, on the main power rail. Or if the short is just, how can I say it? It's not necessary to be on this power rail, but if the short is not after a switching power supply, yeah. So if a short is here and it's just a stupid short, when you lower the current, the voltage, sorry, you lower the voltage, what it will think it will happen, yeah? The current, it will go lower, but I still have 40 milliamps, yeah? So if I go with the voltage high, let's go to 4 volts, 4.1, and the current will goes higher. But we still have a fixed 40 milliamps current because the short, our short, is after a switching power supply, and that switching power supply is regulating the power. Yeah, that's the reason why from 3 volts to 4 volts, I can't see any change here. Okay, that's the only reason. So I can't see anything with the thermal camera, not on this side of the board. And we know our something is taking too much current. I will not say short. I can say short. But, something is taking too much current after a switching power supply. Yeah. So whatever the short it is, it's regulated by a switching power supply. Okay. So I will go further and I'll remove the back cover and I will check something more here. Okay, those are some bad news. Okay, what we have here, exactly this component. Well, anyway, maybe it's not a component. I don't know what to say, but look here, yeah? So checking with the ground, yeah? So checking with the ground. Here you have 0.04 ohms. Here you have 0.02. Okay, so this is a power rail. And the power rail where it is there is this one, yeah? This is the chip. And this is the UFS buck booster, okay? On the what we checked this capacitor. Yeah, that's what we checked. Let me see. Yeah, that's the one. Yeah. So where is that? This chip here? We check on C4002. That's the capacitor. C4002. Okay, so here we have a short. So this looks like it's a ground. This is a plus. Yeah. VBAT. So I believe this is coming from the battery. VBAT. Let's see. The thing is, we don't know what this power rail is doing. Okay. So what I will gonna do? I'll come with a very low voltage. So I really doubt on this phone it will be a power rail lower than 0.5 volts. Yeah. So we are safe. 0.5 volts. It's a very safe value. The short circuit current, let's set up to be like 100 milliamps. 100, 120, 110 milliamps. Okay, let's come with the power with the thermal camera and see where is this short, because I want to see where is this short. Can be, I mean, can be a capacitor, can be, yeah, can be this booster, this chip, or can be something else on this VBAT power rail. Now the current is too low. Let's go higher. 300 milliamps. And even with 300 milliamps, I can't see anything. So 300 is not enough. Let's raise the current to 1 amp. I'm holding on ground right now. Okay, so we raise the current 1 amp. Because can be a semiconductor burn here or just a stupid capacitor. Okay, with 1 amp, I can't really see a short here. So with 1 amp, we can't see anything. With 1 amp, I believe we have to raise the current here. The short resistance is very low, like very low. Most likely a capacitor or like a dead short IC. Let's raise the current to 2 amps. No, we can't go. 1.5 amps is the higher with 0.05 volts. Yeah, that's the highest. And I can see something on this side which is getting extremely hot. You can see it? There. Taking the power off and the heat is going away. So what is here? Here. What is here? What is getting hot? Something is getting hot here. So I don't think it's on this side. I think it's on the other side. Let me be sure I'm holding the ground. You can see it? Yeah, there. I believe it's on the other side of the board. What is on the other side of the board? So exactly here. On the other side of the board, we have a capacitor there, and we have something under this metal thingy. Let me see, according with the schematic, what we have there. So according with the schematic, okay, so that capacitor is again on the same. No, this is a different chip. Sorry. Okay, it's on the VBAT power line. You can see C110. It's on the same VBAT power rail. Yeah. Now let's come with the power on this capacitor and see what is happening. So one more time, this capacitor is here. You can see this one from here, this one. Okay. On our board, it's exactly here, this one. Now let's see under the microscope. Yeah, that's the one. Yeah, so the VBAT power rail, it's on this capacitor. So what I'm gonna do, just to be safe, I'll lower a little bit the current. We have 1.5, let's go to 1 amp. And let's see with the thermal camera if indeed this is the capacitor which is getting hot, okay? So on this side, okay. I can't see any form of heat. Okay, let's raise the current. And if we are raising the current, pay attention, yeah? If we are raising the current, it's exactly that capacitor which is getting hot, you can see. I believe that's the one, right? Yeah, must be. Let's remove this capacitor and check one more time. I mean, can be, even on the other side, can be something else. But at the moment, I'm, I had just a bad feeling with this capacitor. I really miss the other thermal camera. The other thermal camera I can focus closely, but with this one I can't, and it's insane. I have to open this and modify because the focus is adjustable. Anyway, let's remove this capacitor because I don't trust. Something is getting very hot here. Let me grab a small nozzle. Okay, so we remove this big capacitor. This is a big one. Okay, let's check now the power rail for short with the multimeter. And this power rail is not shorted anymore. You remember? You remember on the other side, here, okay, here. You remember we have a short here on this capacitor. Here, we had a short, you remember? Look now, like infinite resistance. Okay? So, do you think we solved the problem? I wish I can know. The only way to find out is to test it. I've seen people, they are funny with replacing capacitors. And on the last videos, oh sorry, I never seen you replacing a capacitor. One day, I will do it. One day, I will do it in one day. I will do it. I will do like a favor for everyone, and I will indeed replace the capacitor. One day, that day it will come. Okay, everything is on place. Yeah, at least everything looks on place. Let's connect the screen. Let's connect the battery. The battery is very discharged, you remember? And let's connect the charger. Okay, that's not good. That's not good. That's not good. Okay. Let's unplug the battery. Let's come with the power supply. Very low current. Let's come to the battery connector. And it's taking nothing. Yeah, you remember we had like 40 milliamps on the beginning. And it's taking nothing, no power. That's good. Okay, let's put some power onto the battery. Yeah. Let's charge the battery just to bring the battery to the working level. Okay, let's raise the current and charge the battery with about 2 amps. Yeah, we have 3.5 and the voltage is going up. Let's charge the battery a little bit. Yeah. When the voltage, like with 2 amps, when the voltage it will reach around 4.2 volts, the real voltage on the battery will be like 3.6 volts. Yeah, so that's about the lowest. Yeah, so we have to charge the battery with till the voltage is reaching 4.2. But obviously, when I will take the current out from the battery, the voltage of the battery will get dropped to 3.6. We spoke about this. So whatever you see on the screen, 3.8, the cell probably right now has around 3 volts, but you get a lot of current lost on the cable, on the electronic board, on my probes. Yeah. So when we have 4.2 there, 4.2 volts, that's mean on the cell, yeah, not on the battery, on the cell, we have 3.6 volts. Let's raise the current. It's unexpected, like, in a phone, a shorted capacitor. Same like laptops. I mean, it's the most common fault. Shorted capacitor. If it's not a shorted capacitor, what it is? A shorted IC. If it's not a shorted IC, what it is? A MOSFET. Okay, we have 4.2. Let's lower the current to 2 amps. Yeah, with 2 amps, when it's 4.2, we have like 3.6 on the battery. Yeah, but should be fine, right? Should be fine. Let's check the battery voltage. And the battery has 3.6, you can see on the screen. So we do have 3.6 on the battery. Plug in the battery. Let's plug the charger. And the charger is shutting down. Okay, that's not good. Actually, I think probably we will have to replace that capacitor. Anyway, let's see if the phone has any sign of life. Yeah. Sign of life. What is the power button? The power button is here, but I think it's connected by the top. Is connected by this? No, probably it's under, right? Oh yeah. Oh yeah. So if we are pressing the power button, what is happening? It's very possible we can have more faults on this phone. Okay, it's doing nothing. I mean, it's dead. Good. Now, what do I want to check? I want to see if I have any reaction from pressing the power button. Yeah. That's an important test to see what the board is doing when you press the power button. Let's lower the voltage, the current. Okay, pressing the power button. Look at the board. You can see, so the board is reacting. So pressing the power button is taking 140 milliamps. Releasing the power button, 0. Okay, so the board is trying to start. You can see, pressing the power button, 140 milliamps. So now is the hard part. I mean, everything looks fine. I have voltage on the power button. The power management chip is reading the power button. Actually, it's working. It's a microcontroller there. It's reading the power button. So it's reading the power button. It's starting some booting sequence, yeah, because you can see the current is going up. But actually, the phone is not doing anything. Okay, so I spent like another half an hour testing, and everything looks fine. I put some tape here because I don't want to see things from the picture, from the screen, yeah? But the phone is okay, and it's working, and everything is fine. I can't believe. So actually I managed to fix it, and the customer can recover their data. Now, I don't want to tell you what the problem was. No, I don't want it. I don't want it because I know from now what it will be on the chat. Okay, so everything is working fine. Yeah. After I tested, and I said, you know what, this looks weird. I mean, it looks weird. And I said, let's solder a capacitor back on the same spot. And after I soldered the capacitor back, actually the phone started. I don't know what to say because usually, I'm not replacing the capacitor. If there is not a capacitor, the capacitor cannot get shorted. But on this case, I really had to replace it. I mean, I know exactly what those capacitor is doing, and the laptops compared with the phones it's a different story. So the power lines, they really have a very low resistance, and the capacitor are important. A capacitor is same like a battery, okay? So what I did, I soldered back on the same spot. Remember, here we removed the shorted capacitor here. So I soldered back another capacitor. That's all what I did on this phone. Okay? I'm happy the phone is working. You have no idea how happy I am. I mean, you have to understand you can run like in some problems, and you can go on a point where you have to swap the CPU and the flash on a different board. This is part of a data recovery job. This is a lot more. I mean, this was an easy one. And if it's a easy, it's cheap for customer. If it's cheap for customer, everyone is happy. But you can run on serious problems on a data recovery job. On a data recovery, because on a normal job, let's be honest, who it will spend time to fix a board? So the issue with this board was this thing. Yeah, this is a capacitor, and if we are checking the capacitor with the multimeter on the ohm range, look, you can see. So the capacitor has like 0.03 ohms. Okay, that was the issue with this board. Okay, this was an easy one. But anyway, I didn't expect my board it will not start with this capacitor. I didn't expect that. I mean, I know it's different compared with the laptop. I know actually the capacitor it will lower the resistance of a power rail. But yeah, I didn't expect it. Let's power on one more time. I think the battery is low. Yeah, it is low, but it's still starting. Okay. So we done the job. I will speak with the customer to save the data from this phone. But anyway, I'll stop now. I'm just, just short video. A short video. This is not a short video, but anyway, this is how you start and diagnose a problem on kind of a safe way. I mean, I didn't push anything. We use a logical approach to the fault. And I will do more video about data recovery. Yeah? So as soon as I will have another job, we're gonna do another video. So I will say thank you for watching. Like and subscribe if you like the video, like always, and see you on the next one. Bye.